So we started looking at numerical methods. Or let me just do an overview. We started the course, looked at what computing is, what programming is. We went further to look at MATLAB, the MATLAB environment, what are some of the features we have in MATLAB. What is MATLAB actually? We went further to look at some basic elements when it comes to MATLAB. Okay, so if you notice the chapter 2 had a lot of the basic elements. And even with that, we didn't do plotting. So I would focus, whatever we do on the polynomial, we'll end up coming up with some plots with it. So we looked at some basics when it comes to MATLAB. So we talked about data types. We looked at variables, predefined variables, how to output and input, and so on. Then we talked about arrays, vectors, and matrices, how to write them. We saw a lot of examples on that. Then we looked at strings as well. We saw how to write commands and some functions or predefined functions in MATLAB. Then we talked about the operators in MATLAB, the various operators, operator priority, and associativity, the input and the output functions. That's the use of the display or the diffs and then the fprintf. And tried a lot of examples. However, we didn't focus much on the plotting. Okay, so we'll do a bit of that today and also recommend a video for you to watch on the plotting. Okay, so we talked about programming in MATLAB. Okay, writing a script. Okay, this time around, not a command. So we saw how to do that. We did a couple of examples. Then we looked at functions. Okay, we talked about functions. So with the functions, we looked at the 4 different types of function. In this context, we focused on user-defined functions. Okay. And then we looked at branching statements where you use the if, else. Then we looked at the loops. That's the statements that repeat themselves or repeat a task in the program, in your program. And then finally, we ended on the numerical methods. That was our last meeting. And so with that, we looked at matrix algebra, looked at some functions, okay, numerical linear algebra functions when it has to do with matrices, and then some data analysis functions as well to find mean, mode, sort, and so on. Okay, so let's look at polynomials. So we know polynomials as expressions that are used, or expressions that we use in expressions in mathematics, or mathematical expressions that consist of some coefficients, and it is used, or it involves operations like addition, subtraction, multiplication, exponentiation, and so on. Okay. So MATLAB provides a number of functions for manipulating polynomials. Okay. one of which is finding the roots of polynomial. So in finding the root of polynomial, MATLAB solves this problem and finds the roots by using the function roots. Okay, so there's a function in MATLAB which is known as the roots function, and it's used to find the roots of a polynomial. So over here, we are given a polynomial, okay, x raised to the power 4 minus 12x cubed plus 0x squared plus 25x plus 16. Okay, so who can tell me the degree of this polynomial? Anyone? All right, so I was saying that in writing your polynomials, okay, so this is when you want to find the roots of the polynomial. Okay, you want to find the roots of this polynomial. So what do? You first represent the coefficients as a vector. You represent the coefficients as a vector. So the coefficient of this value here can you all hear me?
Yes, sir.
Okay.
Yes, sir.
All right. So I was saying the coefficient of this value here is 4. Sorry, it's 1. Okay. The degree is 4. The coefficient is 1. So we represent that here. Then when you take this negative 12 cube, you don't do the 12, but you take the 12 with the negative value. So negative 12. Then the next one is x squared. Okay, so the x squared has a degree, the x squared has the coefficient of 0. So ideally, this would be 0 times x squared, which will give you 0. Okay, so usually when you are writing your polynomials, you do not indicate this. You just keep to the next value, which in this case will be 25x. Okay. However, when you are representing it in MATLAB, you need to indicate that coefficient because it's in that particular order. Okay, so that coefficient has to be indicated there. Okay, then we come to the next one, which is 25, and then the next coefficient, which is 116. Okay. So now after doing this, if you're asked to find your roots, you just pass the value into the root function. Okay, so the root function, you have your p here. So this p is coming from the coefficient that you've written as a vector. Pass it to a function, and then that gives you your roots, or that will give you the roots for your for that polynomial. So let's just do a quick demonstration of this in MATLAB. So basically, you can do this inside your command window. Okay. So the command window, you are given your polynomial. So p equals 1, negative 12, 0, and then 25, and 116. Okay. And you are being told to find the roots the roots of the polynomial. So all you do is introduce the function, but first give it a variable. So r is equal to roots into bracket p. So this is giving you the various roots. And so one of which is 11.7473 plus 00. Okay. So it's giving you 4 different roots of that particular polynomial. Then there's also curve fitting. Okay, so you can be given a situation where you have values which you may have to plot. Okay, so you plot the value. So in this case, we are given values of x, which is starting from 0 all the way to 1 with an interval, okay, of 0.1. I hope you remember those examples we did some time back. So in this context, x is equal to your square bracket is starting from 0 all the way to 1. However, the interval, if you take note of it, you realize that the interval in there is 0.0. Let me write this again. The interval in there is 0.1. Okay, 0.1. So you start from 0. The next value is 0.1, 0.2, 0.3, all the way to the last value, which is 1.0. Okay. Then if you look at it carefully, you are given a y value. So the y value is also given here. I don't think this is in any particular interval. So you've just been given the value. So what you do is that you are going to plot your x against your y. Okay. So as one of the plotting values, plotting functions, which is the polyfix, which is used for solving least square polynomial curve fitting problem. Okay. But I want to talk about, want us to look at a question, okay, that wants us to look at a question. I don't have it in the slide, but I'll just have it projected so that we can all flow with it. So we can use that to plot, come up with a plot. All right, so I hope you can all see my screen.
Yes, sir.
Yes,
okay. So you are given this question and you are told to, so it says given x from -5 to sorry, from -5 to 5 with an interval of 0.5, create a script file and draw the graph of the two polynomials. So the first polynomial is 2x raised to the power 3, and write it correctly. And then 7x raised to the power 2, and then 9. Okay, that's f of x. Then g of x is 5 raised to the power 3 plus 9x plus 2. Okay, so in this question, what you are supposed to do is first solution. First, you are supposed to find your value of x. Okay, and what will x give us? Who can help us? Who can help us from the preamble? What will be x?
The s is equal to the square bracket.
Okay.
I think
Yes.
So 3, 2, or if I'm right.
I didn't get you. Can you repeat yourself again? Yes, Gideon.
Yes, sir. So 2. If
2.
I'm not mistaken. Is it 2 or 3? 2, 7.
No.
Okay,
2,
so
7.
3, 3.
No, so
7.
Look at the question carefully. So it's saying that x is from 5 to -5 to 5 with an interval of 0.5. This is something we did a long time ago.
Okay.
Yes, is it Mauli?
Yes, sir.
Yes, can you help us?
Square bracket.
Square bracket.
-5.
-5.
Colon.
Colon.
0.5.
0.5.
Colon.
Colon.
5.
5.
Square bracket.
So that's our value. Yes, thank you, Maui. So that's our value for x. Okay, so x is from 0.5 to 5 with an interval of this. Okay. So what it means is that your values of x are starting from 5, 4.5, 4.0, then 3.5. Sorry, these are all negative. Okay. 3.5 all the way to 0, all the way to 4, 4.5, and then 5. Okay. So these are your values for x. Okay. Now, this is different from the first thing I explained. The first one, the question was saying that you should find the roots. You were finding the roots. Okay. In this context, you are not finding the roots. It's just saying that plot, okay, these polynomials. Okay, but you've been given x. So now you are going to find your f of x. Please, I hope you are following. Okay.
Yes, sir, we are following.
Okay. In the initial context, it is when you are told to find the roots of the polynomial. That's when you enter the coefficients. Okay. But this context, the question we have now is asking you to plot the graph given your value of x. Okay. So f of x here simply means that for this polynomial, you are going to substitute your x values into it. So if x is -5, substitute -5 into this polynomial, what will you get? If x is -4.5, substitute it, what will you get? Okay, so you do it for all the values of x. Now I'm going to do that for all the values of x, okay? So now we need to represent our f of x by a variable. So let's say f, okay? And then we are going to write this polynomial here in an expression form. Then we will also do the same for g of x. Okay, so for g of x also, we are going to substitute the value of x in there. So let's say g of x should be variable g, and then we'll write this also in a polynomial, in an expression form. Okay, so how do we write this in an expression form? First, we'll take the value 2x raised to the power 3. What it simply means is that 2 times x dot caret 3, right? That's 2 times x, or 2x raised to the power 3. Okay, so that's how we write it. Plus, the next value is what? 7 star x. Okay. Pardon my writing. Okay, dot, and then your caret 2. So that's x, 7x squared. Okay, then finally plus 9. Okay. So when you write your expression in this form, what will happen is that for every value of x, okay, for every value of x, if x is -5, it will substitute -5 into all your x and then give you the answer. Okay, then it comes to the next one. Substitute x into it, perform the computation, gives you the answer, and that answer will be for f. So you find for f, you find all the g of x values as well, and then you plot your f against your g. Okay, you plot your f against the g. Okay. So let's go into MATLAB and try to write this program and come up with a plot. All right, so like we always do, we make sure that we open the folder in which we are going to save the work. So please, just a quick one. I've noticed there's been a change in the course code. So the course code is now CVE 227. Okay, it's now CVE 227. So please take note of that. Okay, so I select my folder, created a folder on desktop where I'll save my work. Okay, so I've selected that folder. So the question says, you should do all this in a script file. Okay, so create a script file and then you draw the graph. So in creating the script file, you go to the Home tab, New Script. So I have my script file created. Okay, so like you always do, your name as a comment, name and ID. So what do we do? The first thing is to find the value of x. Our x is equal to square bracket. So that's what, -5, okay, colon 0.5, colon 5. Then we said that, let me just introduce a comment here. So you can say let f of x equals f, and g of x equals g. Okay, so what is your f of x? F of x is 2 star x, okay, dot, and then your caret 3. Then we do for the next one. So that is for this 2 raised to the power 2x raised to the power 3, or 2x cubed. Then we do for the next one, which is 7x squared. Okay. And then the last one is a coefficient 9. We terminate it. We go to g. G is 5x cubed. Okay, 5x cubed plus 9x. So 9 times x, or 9 star x plus 2. Okay. So what we have here is our code. Okay, so we've done with the first part, we've written the expression for or we've introduced our value for x. Okay, then we've written our expression for f of x and also for g of x. Okay, so before we go further, let's save this. So I'll save this, maybe give it a name, polynomial. So once I save this, let me move this so you can see. So if I run this, you can see it's populated my values for, well, let me just clear the workspace so you can see it very well. So our workspace is empty. So now when I run this, it has populated my workspace for me. Okay, so what is x? When we did our value for x, when I open it, we said x starts from -5, then -4.54, and that order. Okay, all the way to 5. Okay, then f of x. So what it did was it substituted the value. So if x is -5, substitute -5 in here and calculate the corresponding value for f of x, which is for -5. Okay, and that is what is giving us these values here. And then it does the same for g of x as well. okay, after substituting the value of x. Okay. So what is required of us now is to plot. We are going to plot our x against the f of x and then plot the x against the g of x. Okay, so how do we do that? Simply write the function, or you can even do that in the command window. Okay, but for these purposes, since you'll be saving your script file, okay, so you want to, the command window wouldn't save it, wouldn't show in your script file. So you want to write it in the script file and say plot. Okay, what are we plotting? We are plotting x against f. Okay, so the x against f. So when I do this and run, it's supposed to give me the plot of my x. Okay, so you have to label your x-axis and y-axis. Okay, so the x-axis here, sorry, when you go to clear this before, when you go to insert, you can add x label. Okay, there's also codes. I'll show you a link where you can add. I'll show you a link with where I've done some examples on the plotting. Okay, so you can actually write codes here to perform this function. Okay, or you can come to the plot graph and then do it. So come to insert, and then you want to insert a label for your x-axis. So these are x-axis. So x. So the x-axis is, or we can just say x values. And then we insert for the y-axis, which is here. So our y-axis in this context is our f of x. Our f of x. Okay. So this is the plot for it. Okay. Now, if you go through the handout, you would see that under the part which talks about plots, I think in chapter 2, it gives a table which shows the various or how you can differentiate your plots. Okay. So, for instance, yeah, so you can add colors to it. So maybe you have two plots on one. You can add colors to it. We call them the line color, line style, marker style, and legends. Okay. So if you want to make a particular line, maybe yellow, these are the various color codes. Magenta, red, cyan, green, and so on. So you add a color code to it. Then if you want to, instead of color code, if you want to use a marker style, maybe plus, 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 and so on. They are all here. Okay, so I'll just quickly demonstrate how we can do that. Okay, so let me push this here. Okay. So we are supposed to plot our x against our f, and then plot our x also against the g. Okay, so someone can decide to do two of these plots. So we'll come down again and then do x and g. Okay, or you can put it together. Okay. So in doing this, you can say maybe the x of f, the x, plotting the x against your f of x. You want to give it maybe a red color. So what you do is you bring a single quote, and then inside a single quote, you put R there because that's the color code for red. Okay. So as you can see here, red is this. And then maybe we want black. Black is K. Because blue is B, Okay, you can also use the first letter for black as B. So black is K. So we want the G of X to be black. So we just put there and then we say black. So what I'll do is I'll run it again. So in this particular context, what it will do is that it will give you two separate graphs, okay? But we want both lines to show on one graph, on one figure, okay, instead of two separate plots. So what we do is that we'll put this inside the, we'll add it to the first plot, else it's going to give us two separate plots, okay? So after you've done your plot of x against your f, and then that is going to be a red color, you do the plot of x. So separate all with a comma, do your plot of x against your g, and then you make that black. Black is K, sorry. Okay. So when I run it, you can now see it's giving me the two plots. Okay. So after this, I'll add my labels. So this is my x values. And then the y. And set my y. So my y, I'll say f of x and g of x. Okay. Then we want to add a legend. Okay, a legend. So that if anyone sees this plot, the person can see that, okay, the black is my g of x, and then the red is my f of x. Okay, so you go to insert, add a legend. Okay, and then you double click to edit it. So the red is for f of x, and double click, and then change the other one to g of x, the black being the g of x. Okay, so that is it. And then you can even add a title to it. So the title is maybe plotting 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 polynomials. So basically, this is how you go about it. Then when you finish, you have to save this. You have to save whatever you've plotted. So you go to save the figure. Okay. Now we know that when you want to save the workspace, the save as type is what? .mat, right? Then if you are saving your script file, the save as type is .m. Now if you are saving a figure, the save as type is .fig. Or if you are saving a plot, let me put it that way, the save as type is .fig. So maybe I'll just give it a name, say polynomial. dot fig. Okay, and then have it saved. So you can see over here that I have my polynomial saved here. Okay, then also save the workspace. Save the workspace. So you save the workspace. So the workspace, you save it as also polynomial. So you know that these files are all related. So if it's a workspace, it's .mat. So you have it saved. Okay. So just this work, we have 3 files. The figure, which is for the plot, the .m, which is for the script file or the m file, and then we have the .mat, which are the values we add here. Any question? Any question? Any question? All right. Okay. So that's how you perform a plot. Okay, and then label the various axes and the other labels, the legends and so on. Okay. You can, like I said, there are other styles you can use to differentiate your work. So for instance, if you want to do the short dashes, okay, that option is also there. So you specify it. So maybe you want to do short dashes, or you want to do asterisk. So instead of a black line, you want it to be asterisk, or asterisk, just run it. You can see that it's now changed. Okay, instead of black line, it's using the asterisk to represent your plot. All right, so there's so the platform on which I upload the videos, when you go there, let me just go back. And you go to the playlists, okay? You see MATLAB programming for civil engineering. If you go under the video, there's a video there from last year that was on MATLAB functions and plotting examples in MATLAB. Okay, so there's an example which I've done there, which has to do with plotting. Okay, so if you can also watch that. So this is a bar chart or a bar graph. And so on. So you can also watch that to have a fair idea of how to perform plots. Okay. So it's one of the questions that is coming in exams. Okay, so you end up having to plot or come up with a plot. All right, so let's move to the last thing we want to look at. The channel name, it's ATU. ATU, CPS ATU. Okay, CPS ATU. So that's where I upload all my Zoom sessions. So including the videos, the previous links you have, it all leads to this platform. So you can always go there and watch previous videos. Yeah. All right, so the next thing we want to look at quickly has to do with, or the last part of our handout focuses on Excel. Okay, so Microsoft Excel. Okay. Most of these are math functions that you know already. Okay, functions in Excel. Okay, but I want to focus on pivot. Okay, pivot functions in Excel. What I realized was there are some questions coming from there, which I need to talk about briefly for this session. So what are pivots? Or what's a pivot table? Okay, so a pivot table in Excel is a tool that allows you to summarize, analyze, explore, or even present large amounts of data. Okay, so there is a tool in Excel which helps you to analyze data. So as you can see here, I have a data which is in the form of a survey, some data analysis survey that has been conducted that I've just tabulated here. Okay, so what pivot table would help you do is you can do what we call data summarization. You can summarize the data from maybe a large data set by grouping it or aggregating the information that is there. Okay, and you can use some of the functions that have been discussed in the handout to handle that. So the sum function, the count function, average, and so on to handle some of these things. Find the maximum, minimum, and so on. You can also use your pivot table for data analysis, to sort file, to perform filter. You can use it for reporting, okay, performing some reporting or visualization, and so on. Okay. So what I want to do at this point is to take you through, use this example we have here, and take you through how to come up with a pivot table given any data. I'll type out the steps and share them with you. I'll share it with your class reps so you can read on it. All right, so this is a table showing the a survey for data analysis, okay, based on or a table format showing columns such as respondent ID, question, the response they had, the age group, and then the gender. Okay, so the person conducted a survey and asked certain questions on maybe a particular product. So based on satisfaction, okay, what was the response? So there were three main type of questions. There were 15 people who responded. There were three types of question. Okay. One question has to do with satisfaction. Another question has to do with product usage. Another has to do with recommendation. Okay, so you ask the person, are you satisfied with this product? And people gave their response. Okay, so one said very satisfied, another is satisfied, another is neutral, another is dissatisfied, another is very satisfied. So you can see from here, two people claim they are satisfied with the product. Okay. Then when it comes to product usage, how do they use the product? One person says daily, one person uses weekly, one monthly, one rarely uses it, one never uses it. Okay. Then it comes to recommendations. So would you recommend this product to someone? So one person said yes, another says no, yes, no. Okay. Now, based on all the response we have, there are some demographics. So the age group of the people who responded 18 to 25, 26 to 35, 36 to 45. Okay. So you can see within the context of just the satisfaction, okay, we have 2 people within the age of 18 to 25 and 2 people within the age group of 26 to 35 who responded. Okay. Then 1 person from 35 to 36 to 45. Okay. So that has been given for all the 3 questions. Then we have gender. Okay, so gender, male, female, male, female. Okay. So what does the pivot table help you to do? The pivot table will help you to analyze, maybe you want to analyze the data based on the questions. So in terms of satisfaction, okay, what were the response like? You want to analyze it and get maybe in terms of some quantitative analysis. So get values, okay, categorical values to use for your analysis. Okay. So let's look at how that can be done. So to start with, you first select your table, the entire table, okay, the entire range, everything, and then go to insert. Now insert, the very first tab you see there, in the insert tab, you see the pivot table. So you click it, and when you click it, it gives you this window. Please, are you with me? Are you following?
Yes, please.
Okay. So it gives you this table.
Sir, please go over again.
Who is asking for me to go over? Is it Divine?
Yes, please.
What should I go over? Can you be specific?
From the selection of the table. Instead of
So-
you select all the table, then go to it.
So you are supposed to select the table.
Yeah.
So this is our table. Mhm.
Yes, sir.
You select the table, go to insert. I'll spell out the steps for you. I'll send it to you as a document.
Okay.
Yeah. So insert, sorry, select again. And then click on it, go to insert, and then you see pivot table. Then you select it or click on it. So once you do that, it gives you this view. And so you see this, that's create pivot table. So under the create pivot table, you see you have to choose a range. So because we've selected it already, it's giving us a range. Okay. And there's another option which says new worksheet. Okay, so we want the pivot table to be created on a new worksheet. Okay, else if you choose existing worksheet, that means it's going to create it on this same worksheet. Okay, so you choose a new worksheet so that you can see it there, or you can equally have it created here. So the range is selected, then the worksheet, you choose new. So you realize that it's giving us this is the old worksheet with a table, and then the new worksheet, which is worksheet 3. Now, once you do that, the pivot, it is going to build, give you a pivot table field at the far right. Okay, so you can see here pivot table fields. Okay, and it groups them into the various columns that we had. So there was a respondent column, there was a question, there was response, there was age group, and then there was gender. So what you do is, and then when you come down here, you have the various areas. So the areas are under filters, columns, rows, and then values. Okay. So how do you build your pivot table? You choose from the field, okay, and drop it within the area that you want, how you want to perform your analysis. Okay, so for instance, I want to add my questions as a column. They should show in a column. Okay, I want my questions to show in a column. So I'll select the questions, drag it, and put it in a column. So you see that the questions are showing in the column. Okay, and then maybe I want there's questions in the row, the questions in the row, and then I want, so they are showing in the row form. So the first row, we have the product usage, recommendation, and satisfaction. Okay. Then I want maybe the age and the gender, okay, to show in a column form. So if we take product usage, it should show me the age and then the gender, and then give me a quantitative or a tally of the number of people who responded in terms of a particular age or a particular gender when it comes to product usage, the number of response that we had. So I'll move the age, those are the demographics, to the column, and also add the gender to the column. So you can see here the age is here. So 18 to 25. So 18 to 25, there are males and females there. 26 to 35, there are also males and females. And then 36 to 45, there's also males and female. And then we have the grand total. Yeah. So let me just draw some lines so that you can identify it easily. So now let's add the response. So the response will be the value. The response will be the value field. Okay, so I'll drag the response and put them in the value. And then you can see here that it's populated the pivot table for me with the value. So in terms of product usage, there was one female who was between 18 to 25, and there was one male. Okay, so from 18 to 25, 2 people responded. Okay. Then, so this is more of a quantitative value. So you can use some of this approach for your research work when you are doing your quantitative analysis. Okay, I don't know how your civil engineering, your end of SEM, what's it called? The final year project works are like. I don't know what you do in your methodology and all. If you have to do something of a quantitative, okay, research, okay, you can use this to, given the response you have from maybe a questionnaire or something, you can populate it and then use the pivot table to analyze and also come up with some visualizations, some plots, and so on. So in terms of product usage, there was one person who was between the age of 25 to 35, and then 2 people within the age of 36 to 45. Okay, so it gives you the total, the grand total for all, and in all we had 15 respond. Okay, so this particular one is performing the count. Okay, there are other times where you might have to do some other, use other functions. So this is performing count of the response. Okay, so for instance, if you want to change the function regarding the response, that's the values. When you come to the value, aspect down here, okay, you can just make a change. So maybe depending on the problem or the analysis you want to do, you want the field value sorry, the value field settings. When you go there, you can change the function. So maybe you don't want to do count, you want to do a sum of the responses. Even though it's giving you a total of the sum, you want to do average, you want to do maximum, you want to do perform other functions, standard deviation, and so on. Those options are there. Okay. All right, so basically that is it for pivot table. It's not anything difficult. I don't know if some of the groups you saw a question like that in the quiz, the midterm. I think I added one question like that in the midterm. All right, so any question on the pivot table? Any question? So these are the two things I wanted to discuss with you today. Mainly because you see them in the exam, so I had to go over them with you so that when you see it in exams, you can answer them. Any question?
Sir, please, I have a question.
All right. Yes, who is speaking?
Sir, please, for exam purpose, Nathan.
Okay.
Yeah. Okay, sir, please, for exam purpose, are you going to save it, the pivot table and the original table, are you going to save it different, or you have to do it maybe on one page or something like that?
No, so you are saving, whatever you do, you are saving the file as an Excel file. So they are, it's on the same sheet. So whatever you do, you save it as an Excel file. All right, any other question? We'll talk about the format for the exams, the focus areas for the exam shortly. But before that, any question, we've looked at polynomials, how to come up with roots of polynomials, how to plot polynomials given values. And then we've looked at pivot table. So any question on all that we've discussed? Or if you have any question in general, all that we've done this sem, if you have any question, so you can bring it up.
Sir, please, I have a question.
Yes, Jennifer.
Sir, please, the pivot table, before you start, are you going to create the questions response in each group yourself, or it will create it for you?
No, so this is more like it can be used in different or it has different use cases. So it can be in terms of sales, in terms of inventory management, in terms of project management, in terms of academic research. Okay, so for instance, you are doing a research, maybe your final year project, and you are using questionnaires to for your research methods to gather data, okay, primary data for your analysis. It could also be secondary data. Maybe you go to a company and you want maybe data on, let's say, customer data. So in terms of demographic, their behavior, or maybe a sales data, something. The data can come in a primary form. Primary form, for instance, you use questionnaire, and then you come and type your response, and the question and the response you had. Are you getting me, Jennifer?
Yes, please. Yes.
Yeah, or you can also have it in the form of secondary data. Secondary data means that maybe you go to an institution from the data, maybe Ghana Statistical Service. You go to them for maybe data on demographics or something. Okay, so they give you that data. The data comes in the form of Excel file or CSV file, comma separated files. Then you use those or the data you have, that secondary data, which will look in this form, and then you use it to use your pivot table to analyze that data. Yeah. Yes, Benjamin, your hand is up. Yes, Benjamin. Benjamin Soa, do you have a question? Unmute and.
Say, I have a question.
Yes.
Hello?
Okay. Yeah.
Say, please, I just want to ask for the, you see the age group, you explained something that there are two people who weren't satisfied and were satisfied and all that. How will you know that there are two people there or there is only one person or three people?
Oh, so you have the respondents here. So the respondent ID here just shows the number of people who responded. So maybe you've coded them, you've tagged them. So person 1, person 2. Okay. So if you look over here, you can see that, or maybe let me just go to the pivot table. So maybe for product usage, 5 people responded in all. Okay. 5 people responded. So out of that 5 people, 2 of them are within the age group of 18 to 25. 1, which is this one, is from the age group 26 to 35. And then 2 people are in the age group 36 to 45.
Oh, okay.
You get it? So the pivot table is what is helping you perform that count, counting the number of people who responded to that particular question within a particular age group. You get it?
Okay, sir.
This is a much more simple table, but it becomes, you'd appreciate this because this one you can easily see that, oh, these are the 5, let's say product satisfaction. So these are those who responded, the 5 people. And you can see here that 2 people responded when it comes to product satisfaction. Okay, so it's easy to see from this particular example. Now, what if you have a data or an information or an Excel file which has over a record of over, let's say, 500. Okay, you can only use the pivot table to give you this quantitative response rather than going through the table one by one to see who responded and what's their response. Okay. I hope your question has been answered.
Yes, sir. Thank you.
Okay. All right.
So, sir, please, I need to save the Excel first before going to create another pivot table.
No, they are all on the same Excel file.
Okay.
So all you do is just save it. Just save the Excel file. And then once you save it, it will save both your data and then the pivot table. Yeah.
Okay. Thank you, sir.
All right. Okay, you're welcome. All right, so let's quickly talk about the yes, Idrisu.
So you mean with a table, when you highlight everything and you set it in the pivot, it gives you this table. Like you don't
Hey,
have
my
to do
brother,
anything in additional.
I'm assuming you just joined the meeting.
The network is very bad.
Okay, don't worry. I'll share the video, the link to the video with you so that you watch it. We did a couple of things. We just didn't manufacture the table or produce the table by magic. We did a couple of things. So probably when you get the video, you can move to the point and that aspect and see what we did. Like I said, I also give you the steps to this example so that you can use it alongside when you're watching the video. All right, so let me just give you the focus areas for the exams. The exams, it's in two parts. There's a section A part, which is multiple choice questions. So you have a couple of multiple choice questions to choose from, which will cover everything. Everything, most especially, like I keep saying, the chapter 2. Okay, because the chapter 2 is like the basics of everything we've learned in this course, especially when it comes to the MATLAB. So, but there will be other things from other chapters as well. Okay, so that will be the objectives, some of which you've seen in the quiz and the mid-semester exams. And then we have questions on pivot table as well. You see them in the objectives. Then the section B is going to be the practical part. So the practical, you'd have two main questions and you are answering all two main questions. So there will be a question on functions. Okay, as for function, we've done a lot. We've written a lot of MATLAB functions. Okay, so there'll be a question on functions, and then there will be a question on polynomials too. Okay, on polynomials. So what I discussed with you today on the polynomials. Okay, so that will be the section B. The pivot table will be mostly in your objectives, the section A aspect. Okay, so basically that is it for the exams. Any question?
No, sir.